Hello, my name is Neil Coles, and this is my Physics 2212 Magnetic Fields of Permanent Dipole Magnets lab. Introduction. The purpose of this lab was to compare computational and experimental models for the distance of magnetic fields. Some of the principles that we used was by Van Sarvant law, where B equals mu over 4 pi times Q times V cross R hat over R squared, and the magnetic dipole formula, which is B of R equals mu 0 over R, or over 4 pi times 3R hat times R hat times M minus M over R cubed. This is a little preview of the results from the computational model and the magnetic dipole moment. Lab process. In this lab, we needed to start by finding the magnetic sensor in the phone. So what we did was we oriented the phone to magnetic north, and we moved the magnet along perpendicular to the phone to try to find where the magnet was. Once we found where it was, we put a piece of tape down so that we had the X to find the most precise uh, spot of the magnet in the phone. And then we recorded it on and off axis at different distances. So on the right picture, dperp, the distance from there. Here's our experimental data. On the left, all the yellow is the distance that it took for the magnetic field to reach that. And then we were able to find out that the natural log of the magnetic field and the natural log of R gave us a linear graph. And then finding the magnetic dipole moment, we started with the ln of the magnetic field equal to n times the natural log of R plus the natural log of K, which the equation ended up being y equals mx plus b. And then we plugged in our formula from the slide here, and then the slope equaled negative 2.9135, and then the natural log of K was negative 14.308, and when you put that to the e, you get 6.11 e to the negative 7th. And then you set the magnetic field of the bar the magnetic field of the bar equals K times Rn, and the magnetic field of the bar roughly equals the point charge, which was the mu 0 over 4 pi times 2m over R cubed. You set those two equal to each other, and you get the m. In our experiment, we got the m equals 3.005 amps per meter squared. And then this is my code for the glow script. We started by making a cylinder for the magnet, and then we defined the dipole moment using R hat and R mag and the magnetic field. And then over here we used setting up all of our axes where we wanted to our observation location. And then we found the two on-axis magnets or arrows. Then we found 4 off-axis arrows. And then over here we found dperp, and which is 45 degrees from either axis, perpendicular or parallel. And we made an arrow for that. And this was the results of our lab. We found that B axis was greater than the B perpendicular, and it was a little bit stronger. It was stronger, and it was in the opposite direction. D perp was in the negative direction, and you can see the purple D perp over here. Yeah, and then so our experimental magnitude was 5.473 e to the negative fifth, and our computational was 2.819 e to the negative fifth. So they were considerably different. And some potential errors for that was incorrect orientation with the magnetic field with the phone. We could have had it misaligned so that it wasn't straight aligned north. The phone could have gotten bumped throughout the experiment. The phone's sensors may not have been perfect, or we may not have found the precise location. And other magnetic fields could have been in play at close distances. So other magnets, other phones, other computers, the equipment in the lab could have affected the results. What if and why? If you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respects to the Earth's magnetic field, how would your results change? Uh, the orientation between the north of the Earth's field and the phone would be misaligned, which would cause incorrect data because there would be conflicting fields. And what if you were able to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? Uh, I would expect the magnetic field would probably increase by two, but it could be an intermediate amount. And that it will conclude my Physics 2212 lab.